Hi, today I thought we should look at the determinant of a 3 by 3 matrix. I have looked at the determinant of a 2 by 2 matrix already. And so if you need to look at that, just click on the link. I'm just going to link it up now, and then you can watch that video. Let's get started. To find the determinant of a matrix, all you need to do is to pick a particular row or column that you want to use. It doesn't matter which. If you go through the right method, you should still get the same answer. So say I wanted to take a look at the first row here, which contains 1, 2, 3. What I do is to pick the very first element, which is element 1, cancel the row and then cancel the column, and pick the mini matrix that is left there and find the determinant. So the matrix left is -2, 1, 1 and 2. Okay, so I've put these particular braces to show that it's the determinant of that I'm looking for. I would explain more on that in a moment. Now, if I go to the next number here, it's going to be 2. The only thing is I have got to account for the sign of the position of where 2 is. So 1 has the position of a positive. The first one always carries positive. 2 has a negative, 3 has a positive, and the rest of the elements you can interchange. This is a negative, this is a positive, this is a negative, this is a positive, this is a negative, and this is a positive. And so I've got to account for that. So I put -2. Of course, what I want to do again is to cancel the row of 2 and cancel its column. So I've got 4, 1, 0, 2 left. So 4, 1, 0, 2. And then for the next one, we have +3, so +3. And what I want to do again is to cancel its row and cancel its column, so that I've got 4, -2, 0, and 1. 4, -2, 0, and 1. First step is done. What we want to do now is to simplify what we have. So let's see how that goes. This is 1 outside. We don't need to put it since it's just 1. And then we multiply the leading diagonal here. So -2 times 2, which is -4. And then we subtract, and then we multiply this one, which is 1 times 1, which is also 1. And then next I pick -2. And then I multiply the element in the leading diagonal here, which is 8. And then I subtract 0. Then +3. I multiply the element in the leading diagonal, which is 4. And then I subtract 0. Next, we simplify what is left. So we have -5, -10, +7. Okay. Next, we simplify what we have. So we have -5, -16, and +12. If we do that, this should give us -9. And that's the determinant of matrix A. Just to show that what we have done, we could do it using any other row or column, I am deciding to choose this column 2 to also find the determinant. So if I do that, the first element here is 2. Of course, it's got a negative, so -2 will begin. And then the mini matrix, of course, will be 4, 1, 0, 2, 4, 1, 0, 2. And then next, I'm going to choose -2. Remember that the signage there is positive, so it's positive, however, it's -2. Remember that. And then if I cancel the row and cancel this column, I've got 1, 3, 0, 2, 1, 3, 0, 2. And then next is 1, but because it's negative, that's -1. Cancel his row, cancel his column. I've got 1, 3, 4, 1. 1, 3, 4, 1. And the next what we want to do is to simplify that. So -2. In the leading diagonal there, I've got a product of 8, then -0. Then here, we have -2. And a product of 2 in the leading diagonal, -0. Here I've got -1. -1 that should be, sorry. So -1. A product here of 1 minus a product here of 12. Okay, next we simplify what we got. -2 times 8 is -16. This is -4. And this is +11. If I do that, I would have -9. That's my answer. So of course, if you continue using any row or column, you will get the same answer as -9. Okay, that's it about the determinant of a matrix. In the next video, what I want to do is to try to find the inverse of a 3 by 3 matrix. All right, see you. Bye.